Hey, it's Coach Reeves. Hey, we're here to help you with 4.2 review. So I'm going to do a bunch of problems. This may take me a while, but we're going to get it done to hopefully get you ready for the test. Okay? All right, first one they're going to ask you to do is they're going to ask you to simplify the radical. Okay? This is a big number. We're looking for groups of 4. But look, this is an even root. Remember, if we're taking the even root, we may end up with an odd exponent and have to put them in absolute value, okay? But we'll take that step at a time. But first of all, 486, that's a little bit too big for me. So I need to look for the prime factorization. I need to see what 486 is going to give me. So I'm going to go to my calculator, and I'm going to say menu, number, factor, and we're going to say 486. We're going to hit enter. And my factorization is going to be 2 times 3 to the 5th. So we're going to say, come back to this, and we're going to say this is going to be 2 times 3 to the 5th. Now, it all depends what your comfort zone is, but if you want to string that out, and if you want to come in and say that is 1, 2, 3, 4, 5, I'm okay with that. But what are we looking for? We're looking for groups of 4 because we're taking the 4th root. That means we would come in and circle 1, 2, 3, 4. A 3 would come out. 1, 3, and 1, 2 would stay inside. A 3 is out, but 2 times 3, 6 is inside. So we're going to drop down. We're going to say that we're dealing with the 4th root. We said that we have a 3 on the outside, and we said we're going to have 6 on the inside. Got it? The next thing we like to do is we like to divide. Okay, so I would say that 4 goes into 4. Looking at the exponent on the A, 4 goes into 4 one time, and that lets me take out an A. And then we would say, does 4 go into 2? No, we don't have enough, so the b squared will stay inside. And then we go 4 goes into 6. 4 goes into 6 one time with 2 left over. So now what I'm looking at, okay, now what I'm looking at is I have to determine, I have an even root, but I ended up with an odd exponent, so I have to put that in absolute value. I ended up with another odd exponent, so I had to put that in absolute value. So when you're taking an even root and your answer takes out an odd exponent, you need to put that in absolute value. Okay? All right, let's keep moving. We're going to simplify this. Okay? We're going to rationalize the denominator. We're not allowed to leave a radical in the denominator. Okay? So we want to take this small bites at a time, reduce when we can before we rationalize. I have a 3 outside a squared and I have a 5 outside. I cannot reduce that. So we're going to set this up, and I know for a fact, okay, I know for a fact that I have a 3 outside and a squared. At the bottom, I have a 5, okay? Look what I have inside. I have the 4th root of b to the 4. That matches. My root matches my exponent. I'm going to take out a b. So that b is gone. I don't have to worry about the b anymore. But what I do have left over is I have the the 4th root. I have the 4th root of 9. Is there another way that we can write the number 9 as an exponent? So we're going to convert that 9 to 3 squared. We're going to write that 9 as 3 squared. And then I'm going to have a to the 3rd. My goal is to get, see this root? My goal is to get the exponents to match the root. when the exponents match the root, whatever is underneath the radical will just drop out. So in this case, I need to determine what to multiply times. Because when we multiply, we add our exponents, correct? So we're going to multiply times the fourth root, and this is 3 squared, so I need 2 more 3's. Because when I multiply, 2 plus 2 will give me 4. In this case, I also need a to the first. And whatever I do to the bottom, I must do to the top. So whatever I do to the bottom, I'm going to multiply the top, the numerator, the fourth root of 3 squared, a. So what is this going to give me? 3 squared times 3 squared will give me 3 to the fourth. A to the third, a to the first, when I multiply them, this is give me a to the fourth. Now, my root matches my exponent, my root matches my exponent, so the 3 drops out. My root matches the exponent, so my a drops out. These are outside. 5b is outside. That is going to give me a total of 15ab for my denominator. Up top, look what we have. I have a 3a squared outside. Inside, I'm going to change that 3 squared to a 9. So I have the fourth root of 9a inside. Is it possible to reduce what I have? Yes, I can reduce this. I can come in and I can reduce this, and I can say that 3 goes into 3, 3 goes into 3 one time, 3 goes into 15 5 times. I can also reduce my a's. I have a to the second over a. This can reduce to where there's just an a at the top. This will leave me with an a at the top, the fourth root of 9a. All that is my numerator. In the denominator, I'm left with 5b. There's my answer. This is probably one of the trickiest things we're going to have to do on the test, is rationalize the denominator. Okay? All right, moving forward. They're going to ask me to solve this equation. Okay? This is called a rational exponent. All right? And here's what I need you to focus on. You should have a note, so you have it somewhere in your review or on your worksheet. I need you to look real quick. If that starting numerator is even, then we're going to have to use a positive negative in the equation when we solve it. Okay? And I'll remind you, we did some worksheets. I've done a video and I've shown you, but I'm going to review you to make sure you understand this. Okay? My goal is to get the exponent portion. My goal is to get that by itself. I need to move things away from it. So the first thing that I want to move is the 4. So we're going to come in and I'm going to move this 4. I'm going to say minus 4, negative 80 equals negative 5, parentheses, negative 8 minus 2x raised to the 4/3. My parentheses portion is still not by itself. What I need to do is I need to come in and I need to divide. I need to divide by negative 5. So when I divide by negative 5, this will cancel. This will give me 16 equals negative x minus 2x raised to the 4/3. Now, if you remember, I need to make that 4/3 go away now. Now that the parentheses portion is by itself, I need to make that exponent disappear. And the way that we do this is we're going to raise the power to the reciprocal. We're going to raise the power to the reciprocal. And whatever we do to one side, we must do to the other. But what you remember is now this 4 at the bottom is an even root. We are taking the even root. So that means when we put this in our calculator here, I will get a positive negative number. When we take the even root, we end up with the positive negative version of that number. Okay? So this is going to cancel. This is going to drop out for me, and this is going to be negative 8 minus 2x. But I can't do this in my head. So I'm going to use my calculator of 16 raised to the 3/4. Go to your calculator. We're going to input, we're going to say 16 raised over here to the left of the 4, the carrot top or the rooftop. 16, oops, too much. Let's try this, too much. Here we go. 16 raised to the 3 divided by 4. 16 to the 3/4, and we're going to say enter, and it says it's going to be 8. But we're taking an even root, so it's going to be a positive negative 8. So back on our problem, this will equal a positive and a negative 8. Now I need to work this equation both ways. I need to work it as a positive 8. I need to work it as a negative 8. So I would like for you to come over here and say positive 8 equals negative 8 minus 2x. And then we'd also come over here and choose it as a negative 8. We'll say negative 8 equals negative 8 minus 2x. So to solve this, I'm going to go plus 8 plus 8. 16 equals negative 2x. Divide by negative 2, divide by negative 2, negative 8 equals x. There's one of my solutions. Plus 8 plus 8, that gives me a 0. 0 equals a negative 2x. We divide by negative 2, divide by negative 2, 0 equals x. Those are my two solutions. Those are my two answers. Okay? Takes a few steps. Here's what you need to remember. When we start our initial problem, very beginning of the problem, if the numerator is even, we're going to need a positive negative version during the problem. Okay? All right. Let's keep moving. They're going to ask me to solve the equation, and we're going to check for extraneous solutions, especially when you have a variable outside the radical. Okay? So my first thing is I want to get my radical by itself. So I'm going to move my m to the other side. We're going to go plus m plus m. This will give me 3m, the square root of 3m plus 1 equals m minus 3. Now that my radical is by itself, I'm going to square it so it will drop out. So we're going to jump over here and we're going to say square. And if I square the left side, I have to square the right side. This will drop out of the radical as 3m plus 1. Over here, I need to FOIL this. So we can come over here and we can do however you want to do it. You can say m minus 3 times m minus 3. You can even use the box method. What's going to happen is you're going to multiply and get m squared. You're going to multiply and get negative 3m. You're going to multiply inside and get another negative 3m. And then multiply and get a positive 9. And then you're going to combine like terms. I should end up with m squared minus 6m plus 9. Now we need to solve this, so we need to move everything to get a 0. Okay? So we're going to ask you to go minus 3m, minus 3m, minus 1, minus 1. These are gone now, and I get 0 equals m squared minus 9m plus 8. We need to factor this. We will factor this into two parentheses, okay? So we're going to get 0 equals in our two parentheses. This tells me that my signs will be the same. This tells me that they're both going to be minuses. We're going to break down m squared as m times m. And then our 8, okay, this is a positive 8. This is a positive 8, which means we're going to add to find my combination. I either have 1 times 8 or I have 2 times 4. In this case, we're looking for a combination that adds up to 9. We will use 1 and 8. Now, we can put each parenthesis equal to 0, or we can just take the opposites. And we take the opposites, and we're going to get a positive 1, and we're going to get a positive 8. I need to check these. I need to substitute these in to see if they make true statements, to see if I have an extraneous solution. My suggestion is you go to right here, up here where we had the original problem, before we squared. Now you can go to the original problem, but I like to go here. I like to substitute right there before we squared, okay? Right after we move the m to the other side, I like to substitute here. Because if I substitute my 1, and I put my 1 right there, what is 1 minus 3? 1 minus 3 is a negative 2. And in our rules, we cannot have a square root that equals a negative number. Remember the rules we did in the earlier video, and your teachers have taught you? All right, your radical, your square root cannot equal a negative number. That will kill that 1 as an answer. Let's try our 8. We put an 8 here. 8 minus 3 equals 5. All right, then we substitute our 8 here. 3 times 8 is 24. 24 plus 1 is 25. What is the square root of 25? It's 5. This checks. You need to make sure that you check your problems, your solutions, to see if any of them are extraneous. Okay? Keep moving. All right, so we need to solve this equation. Our goal is if the root matches the exponent, whatever is inside will drop out. My root is a 4. So if I can have an exponent, or if I can raise this to the 4th power, the root would match the exponent and it would drop out. And whatever I do to the left side, I must do to the right side. So the root matches the exponent, so b minus 2 over 6 equals, that's dropping out, 4 to the 4th power. 4 times 4 is 16. 16 times 4 is 64. And that starts getting big, but 64 times 4, it will give you 256. Please use your calculator. Please use your calculator and put 4 to the 4th power in it and get 256. All right, now I'm at my end, okay? Because when I need to move the 6, I'm going to multiply times 6 times 6. This will allow this to cancel. This is going to leave me with b minus 2, but I can't do 256 times 6 in my head. So I'm going to go to my calculator. No. And I'm going to go 256 times 6. And that gives me 1,536. So I go back and I say this equals 1,536. I need to move the 2, so I go plus 2, plus 2. That's going to give me b equals 1,538. There's my answer, 1,538. Good. All right, they're going to ask me to simplify this expression. These are the easy ones. These are the ones that I use the calculator on because I can't do these in my head. But this 4/5, this exponent of 4/5 goes to this number and it also goes to that exponent. So what I'm going to ask you to do is put 243 to the 4/5 in your calculator. And then we're going to come over here and we're going to say that x to the 10th is being raised also to the 4/5. Okay, because that 4/5 goes to 243 and it also goes to x to the 10th. Okay, so I don't know what this is. Let's go to our calculator. So it says 243 raised to the 4/5. 4 divided by 5. Enter. And that's going to give me what? It's going to give me an 81 as my answer. So we go back and we said that this is going to give us an 81. 243 to the 4/5 is 81. Now, when you raise the power, remember we are raising the power. That's going to go 10 times 4/5. Because when you raise the power, you multiply. And this is going to give me 40 divided by 5, which is 8. This is going to give me x to the 8th power. If you know the process, this is a really easy problem. Hopefully this is one we're going to help you grade with, okay? All right, let's try another one. Next problem. They want you to graph. We're going to graph this, okay? So the first thing I want you to do when we graph is I want you to determine your starting point. Determine your starting point. Don't look at your A, look at anything in front of the radical. This is going to tell me to shift. Remember, we're thinking opposite here. This is going to tell me to go to the left 2, and this is going to say to go up 3. So we're going to go left 2, up 3, and there is my starting point. From there, we need to apply our stretch and shrink or our reflect, if we're going to have a vertical reflection or not. So in this case, I have a vertical reflection. I'm going to go downward. And I'm going to have a vertical compression. I'm going to get a little flatter. But what I'm going to do is I'm going to put some points. I'm going to try to graph the parent function. And then I'll apply this. Okay? My parent function says the square root of 1 is 1. The square root of 1, 2, 3, 4. The square root of 4 is 2. The square root of 1, 2, 3, 4, 5, 6, 7, 8, 9 is 3. That's your parent function. Your parent function should look like that. That's just the normal parent function with a vertical reflection. But I want to go what? I want to go half of that. Okay? I need to be half that. So what I'm going to do, instead of going the square root of 1, instead of being 1, I want to be half of 1. The square root of 4, instead of being at 2, half of 2 is 1. The square root of 9, the square root of 9 is 3, but half of 3 is 1.5. I'm picking half of all of those values. Now, what could else you could also put this in your calculator. The easy way, I would do this if you had it, and go put this in your calculator and go Control T. Look at your table and find some points to plot and connect the dots. It's an easy way, okay? All right, let's keep going. They're going to ask us to list your transformations. This is pretty simple, okay? We're going to work left to right. If I have this negative inside, this is going to tell me that I have a vertical reflection over the x-axis. The 5 is separate from the negative. The 5 is greater than 1 because they tell you to look for the absolute value, but the 5 is greater than 1. That's going to be a vertical stretch by 5. By a factor of 5. Okay? The next thing I look inside the radical. Look inside the radical. This will tell me that I have a horizontal shift or a translation. Now remember, we're thinking opposite with this guy, so we're going to go to the right 3. And at the very back end, our K value will tell us if we have a vertical shift up or down or a vertical translation. We're going to say we have a vertical shift. In this case, we're going to say up 1. Now the transformation should be pretty simple for you because it's the same things we've been doing with the quadratics and with the absolute value. Okay? All right, let's keep going. They're going to ask you to find the inverse and state the domain and range of the inverse. Okay? Well, I'm going to change it up first. I'm going to find the domain and range of this problem in just a second. Okay? But this bothers me. I don't like the way this is written. I am a lot more comfortable if it's written like this. Y equals the square root of x plus 3, and I like the k value to be at the very back end. That makes me more comfortable, so I'm going to rewrite my problem to where it's normal, okay? Now, to find my domain, what we have told you to find your domain, you need to look underneath your radical, or inside the radical, and remember, we're thinking the opposite. So when we think the opposite, my number is going to be a -3. So for my domain, my number is -3, and we're going to give that a hard bracket. Now my graph is going to go to the right forever, so we're going to say comma, and we're going to say positive infinity. There is my domain. To find my range, we've asked you to look for your k value at the back end. So my range is going to be off of a 2. We're going to give it a hard bracket, and we have to make a decision. We look at our a value up front. There's not any numbers up front, but we know it's positive, so my graph will go up instead of having a downward curve on a vertical reflection. This one will go up forever to positive infinity. So we're going to say comma, positive infinity. Now this is the domain and range of the original problem. But they're going to ask you to find what? The inverse and the domain and range of the inverse. So to find the inverse, domain and range, remember we just switch places with the domain and range. So my inverse domain is going to come from the range. It'll be 2, comma, positive infinity. My range will come from the original domain. It will be hard bracket -3 to positive infinity. Now we have just taken care of the domain and range of the inverse. Let's find the inverse of this equation. Step 1, to find your inverse, switch places with the x and the y. So we will ask you to write x equals the square root of y plus 3 plus 2. My goal is to try to get the radical by itself. So to do this, I'm going to move the 2 to the other side. So we're going to subtract 2 from both sides. I will get x minus 2 equals the square root of y plus 3. Now, as soon as we move this to the other side, I've asked my students, and I'm going to ask you, please put this in parentheses and create it as one chunk. Keep it right there together. Now that my radical is by itself, if I can get that root to match an exponent, it will drop out. My root is an invisible 2, so we're going to take and we're going to square this, because now my root will match my exponent. This will drop out. Whatever I do to one side of the equation, I will do to the other. I will square that also. I'm going to square this whole thing. So this stays as x minus 2 quantity squared. I only have one step left. I need to move the 3 to the other side. I will go minus 3, this will cancel. My final answer should be y equals x minus 2 squared minus 3. There is the inverse, okay? And we've already found the inverse domain and range. All right, let's go to another problem. Rewrite the expression as a radical. Remember, this is where I drew that goofy picture of a tree and the roots were at the bottom, okay? Remember, I'm gonna do it anyway. I have a tree. Ugliest tree ever, okay? But the roots for the tree, the roots are at the bottom. So when we convert this to an exponent, and that exponent's gonna be a fraction, I need you to remember when the fraction happens, the roots are at the bottom. That's where you find the roots, okay? So we're gonna write a radical because they're gonna ask us to convert it to a radical. My problem is in parentheses. So we're gonna put this in parentheses. What is my root? My root goes in this little nook, but what is my root? My root is at the bottom, so my root goes right there. There's my root. The exponent goes at the top, and what is my number? Or my expression is 6x. Remember, roots are at the bottom. Root is at the bottom. Okay? I know, I'm goofy. Here we go. Rewrite the radical in exponential form. So now I have to convert that to an exponent. So I still have a 3a. That will stay in parentheses. My exponent will be a fraction. My exponent will be a fraction. Where did we say the roots are? The roots are where? At the bottom, in the denominator. So my root is an invisible little 2 sitting right there. That's your root. So my root is a 2. My exponent is a 5. Easy peasy. All right, keep going. All right. This is not actually true. This is just a word problem I made up for one of my teachers. Okay. All right, Coach Troop was a huge hit with the fans in Rio de Janeiro while he was there competing in the Olympics as a cyclist. The locals even painted a large rectangular mural on the side of a building to celebrate his victory. The mural had a dimensions of the square root of 32, a to the 6b squared as its length. There's your length. What's our shape? Rectangular. And it gives you this radical as its width. Okay, so this is determine the area. How do you find area? If I have a rectangle and they're asking me to determine the area, what's the formula to find area? Length times width. This is your length. This is your width. So we need to multiply those together. So we're going to come up and we're going to say the square root of 32 a to the 6th b squared times the square root of 12 a to the 3rd b to the 4th. When you multiply, it's the same root, but when you multiply the radicals, I like to say inside times inside will stay inside. And then we reduce or simplify. So we need to go and we're going to get the square root, but I need to go 32 times 12. I don't know what 32 times 12 is, so let's use the calculator. Okay? So I'm going to ask you to go to 32 times 12, and I'm going to hit enter, and that's going to be 384. But I'm going to tell you right now, we're going to have to simplify. I don't know what that is as a factored form in prime factorization. So we're going to go ahead and find the prime factorization. We're going to say menu, number, factor, and we're going to say 384. That's our number, 384, and we're going to hit enter. That's going to give me 2 to the 7th times 3. So we're over here, and we go back, it says 2 to the 7th times 3. This is 384 which we said 2 to the 7th times 3. Don't forget that. Okay, we're going to need that. When we multiply, we add exponents. So a to the 6th, a to the 3rd gives me a to the 9th. B to the 2nd, b to the 4th gives me b to the what? B to the 6th. Okay, now be careful. We're taking an even root. We're taking the square root. So if you take an even root and you simplify, if you get an odd exponent, you got to put it in the absolute value. Okay? All right, so we just said that I'm going to have, some of you like this, so I'm going to do what you like to do. There are 7 2's. So we're going to say 1, 2, 3, 4, 5, 6, 7, and a 3. But we're looking for what? We're taking the square root, so we're looking for groups of 2. So here's a group of 2, here's a group of 2, here's a group of 2. I get to take out a 2, I get to take out a 2, I get to take out a 2. This 2 is not paired up, that 3 is not paired up. So I'm taking out 2 times 2 is 4, 4 times 2 is 8. I have an 8 coming out, okay? I have an 8 coming out. I have 2 times 3, which is 6. I have 6 staying inside. Look at this now. There's an invisible 2 sitting right there because we're taking the square root. I'm going to say that 2 goes into 9 how many times? 2 goes into 9 4 times with 1 left over. 2 goes into 6 how many times? 3 times. We took an even root. Did we end up with an odd exponent? Yes. We ended up with an odd exponent, so I need to put this guy in absolute value. Okay? I think I have a couple more pages. A couple more problems. This is a tricky one. The last problem is the hardest one. Okay? Now, I don't think your test, you're going to may have one like this, but it won't be quite this hard. So this will get you ready, okay? I cannot work this problem with both radicals on the same side of the equation. And to really make it easy, I would like to have the small radical and this constant on the same side. I would like them to have them on the same side together, okay? But I'd also like to have this guy as a positive. So I'm going to rearrange this to where it's easy to work. I want to move this guy over here. So I'm going to go plus the square root of x plus 8 plus the square root of x plus 8. But here's the trick. I also want to move this guy over here to make it easier. Trust me, this makes it a lot easier. I'm going to go minus 8. I'm going to go minus 8. Okay, so this is gone. This is gone. I'm left with the square root of x minus 8 equals the square root of x plus 8. All right, take a breath. What did we just do? I moved this one to the other side and it became positive. I moved this 8 to the other side and it became a minus. My radical is by itself. So what I would like to do is I would like to square this. If I square this, whatever's inside will just drop out. So this is just going to drop out as an x plus 8. I'm going to square this. But this is the tricky part, okay? I've got to come over here and I'm going to show you, I'm going to go the square root of x minus 8 times the square root of x minus 8. Now we're going to go step by step, but don't panic. We haven't done anything tricky because we know that we've dropped stuff out before. All right, so stay with me. The square root of x times x. When you multiply a radical times itself, or excuse me, a square root times itself, it comes out. So the square root of x times the square root of x will just leave me with an x. The square root of x times negative 8, outside stays outside, inside stays inside. This will give me negative 8 square roots of x. Now we come over here inside, and we say negative 8 times the square root of x. That gives us another negative 8 square roots of x. And then we come to the back end and distribute, and negative 8 times negative 8 is a positive 64. We will combine like terms. And that, when we combine like terms, will give us this. Let me move this to the top and let you see some better. That will give me x minus 16 square roots of x plus 64. Okay? So now we have to move things. We want to try to combine things, but my goal is to do this. My goal is to get this guy by itself. I want to get that radical by itself so I can solve. So how do we do this? We start moving things. So if I try to move the x's, look what happens when we try to move the x's. They're going to cancel. And I'm going to be left with the negative 16 square root of x plus 64 equals 8. Okay? So now what do I do? Well, we're going to subtract 64. We're going to say minus 64. Minus 64. So when we do this, let me move this so you can see better. This is going to cancel, okay? And that's going to give me negative 16x, square roots of x, equals, and that's going to give me a negative 58. Excuse me, negative 56. I don't know what I was thinking. Okay, negative 56. Almost. Okay, so now on this problem, we're going to divide by negative 16. Divide by negative 16. This is going to cancel. I get the square root of x equals, we're going to try to reduce our fraction. Okay, the negatives will cancel. 8 will go, these are going to cancel. 8 will go into 56 7 times. 8 will go into 16 2 times. I have reduced. Okay? What's left? To get rid of that radical, we're going to square both sides. The x will come out. 7 times 7 is 49. 2 times 2 is 4. Tough problem. I don't think we'll give you something that hard on the test, but at least you know what's going on and you know how to do this. Okay? All right, look, I've gone through a bunch, almost half the entire review sheet. Please do the other half of the review sheet. All right, check your answers. Get with us if you don't understand how to do a certain concept. All right? We want you to do well on your test. Good luck.